there are going to be times when the quadratics that you're faced with, you're not going to be able to factor like we did in Unit 4. So you can still solve quadratics even though factoring may not be an option. So the first way we're going to talk about solving quadratics is using the square root method. And the most important thing that you can remember about this lesson is if you're presented with a problem in which you create the radical, then you need to put a plus or minus in front of it. If the radical is already there, then the positive or negative has already been assigned to it. But if you're solving an equation and the radical is not part of the original equation, and you use the radical to help solve it, you need to remember that there are two solutions at that point, one of which is positive and one of which is negative. And we'll come back to this a little bit later on in the examples. Just as a quick review, it's going to be imperative that you know all of your square roots. So I have here the list of all the square roots from 1 to 20. And so just a quick review of how to simplify square roots is you look at the problem, which in this case is the square root of 80. And then you come over here and you say, well, the square root of 80 is going to fall between these two. So you know the answer is going to be between 8 and 9, but you're not sure what. And we don't want to have the answer in decimal form. We're going to leave the answer in radical form. So look at all of the options, and there's no use in looking above 80. So can 80, no, 81's too big. So can 64 go into 80? No. 49? No. 36? No. 25? No. Can 16 go into 80? Yes. So we always start with the highest number and you work yourself down until you find a perfect square that divides evenly into the square root of 80. So this becomes the square root of 16 times 5, because 16 times 5 is 80. And using our properties of radicals, we're going to call that the square root of 16 times the square root of 5, because the square root of a product is the product of the square roots. And then this is where it's going to come into play. The square root of 16 is 4 square root of 5. So 4 square root of 5 is the simplest radical form for the square root of 80. So you're going to need to be able to simplify your radicals, which you learned how to do that in Algebra 1, but I just wanted to go over it with you one more time. Now, to get into the actual lesson, we're going to be solving quadratics using the square root method. The first thing you're going to want to do is isolate the squared term. That doesn't mean isolate the variable. It means isolate whatever is being raised to the exponent of 2. Sometimes that's going to just be an x or an s or an a. Sometimes it might be more than that. It might be x minus 3. Both the x and the minus 3 belong to the squared term. So this is the squared term that you're going to want to get by itself. Once you've isolated the squared term, and you've gotten everything else on the other side of the equation, then you're ready to take the square root of each side. Why would you do that? Because a square root undoes a square. Cancels that out, and it allows you just to say x. But this is what I talked about on the front page. It's actually plus or minus x. That square root was not originally part of the problem. I chose to put it there in an effort to get rid of a square, so the answer must be plus or minus. And then the last thing would be if your variable is not by itself, at that point you're going to want to get the variable by itself. So let's put these steps into use. Okay, so isolate the squared term. X is the only thing being raised to the exponent of 2, so we've isolated the squared term. So then you're going to take the square root of that side, and you're going to take the square root of the other side. Now, again, I chose to put the square root there. I don't want to forget my plus or minus. The square root takes out the square. You're just left with x equals plus or minus. And the largest perfect square that can go into 144 is 12, and it actually goes in evenly. So there's two answers here for the solution to this equation, positive 12 and negative 12. 12 times 12 is 144. So that works. But negative 12 times negative 12 is also 144. So that's why we're going to get two solutions here, because there's two different numbers that give me 144 when you square them. All right. Now, if you look at this example, the squared term is not by itself yet. Okay. Now that 3 does not belong to the exponent of 2, so I'm going to need to get rid of that as well. But you always want to work towards this. So the first thing we're going to get rid of is this minus 213 right here. We're going to add 213 to each side. These guys are going to cross out. So I have 3x squared equals 213. Now we still haven't isolated the squared term. You want to get rid of this 3 because that 3 does not belong to the squared. So now we have x squared equals 71. Okay, so we've isolated the squared term. Then you take the square root of each side. The square root takes out the square. But when we did that, we picked up a plus or a minus. So we're left with x is equal to plus or minus. And then you want to see if you can simplify the square root of 71. So start there and work your way down. The largest perfect square below 71 would be 64, but that doesn't go. So then you're going to try 49, and that's not going to go. You're going to try 36. You're going to try 25. We can try 16. We can try 9. We can try 4. And so we've gone through the whole list. There's nothing to simplify here. So your answer would just simply be plus or minus the square root of 71. You can always check that by plugging those values back in for x and making sure this equation works out well. Okay, in the third example, again, you want to isolate the squared term, so we want to get rid of our 4. That 4 does not belong to the squared. The only thing belongs to the squared is this x minus 1. So you have x minus 1 squared. And 8 divided by 4 is 2. All right, we've isolated the square term. You're ready to take the square root. Square root. Your square root takes out your square. So we have x minus 1. And over here, I need to bring in that plus or minus the square root of 2. All right, we remembered our plus or minus, so we're going to solve the variable. This is an example of just because you took the square root doesn't mean you're ready. The answer is going to just be there. Once you've taken the square root, we still need to solve for x. So we're going to add 1 to each side. These guys cross out. So x is equal to 1 plus or minus the square root of 2. Again, there's two answers. It's a quadratic. So the first answer would be 1 plus the square root of 2, and a separate answer would be 1 minus the square root of 2. All right, let's look at one more example. This is a little bit more involved. Here's your squared term. So we're going to need to get rid of this 7 right here and this minus 18. So this is the furthest away, so we're going to start there. We're going to bring that 18 over here with a 10, which is already on the other side. So we have 7 times x minus 4 squared. These guys cancel out. That equals 28. Divide by 7. Divide by 7. So now we've got that squared term isolated. It's x minus 4 quantity squared. 28 over 7 is 4. So then we're ready to take the square root of each side. The square root takes out the square. So we're left with x minus 4. I just took the square root, which means I need to put a plus or minus here. And the square root of 4 simplifies to 2. We're going to add the 4 over because we want to solve for the variable. And so you get x equals plus or minus 2 plus 4. If you work those separate equations out, positive 2 plus 4 is 6, and then negative 2 plus 4 is 2. So those would be your two solutions. Alright, we're just going to leave it at that for right now, and go ahead and have a try at your classwork, and let's see how you do with that.